either use angle, angle, side, angle, side, or side, side, side. Those are the only three options that we have right now for showing that two triangles are similar. So let's go ahead and test that out, see how good we are. So let's look at our first pair of triangles right here. All right, what options do we have? Could we use angle, angle at all? Hopefully you said no, because notice we don't have the measure of any of the angles. We don't have any congruent markings. So if these two triangles are going to be similar, it has to be using proportional sides. It has to use side, 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 because we don't have any angles to go from. So what I do now is set up my fractions to see if I have equal fractions here. Okay, so line up your corresponding sides. The longest side of this triangle, which is actually down here, 12 is the longest side of this triangle, should match up with the longest side of this triangle. So 12 to 6. The next longest side on this triangle was 10. It should match with the next longest side on this triangle, 5. So 10 over 5. And finally, we have our shortest side of this triangle should match up with the shortest side of this triangle, 8 to 4. Reduce each of those. 12 divided by 6 is 2. 10 divided by 5 is 2. And 8 divided by 4 is 2. Notice they all equal the same thing. So yes, these triangles are similar. And they are similar by side, side, side. Okay, let's take a look at our next one. Here's our next pair. Do any of our little postulates over here work for these two? First of all, what could we use? When you look, notice I don't have the measure of any of the sides. None of them are labeled with a measure. Therefore, I cannot use side, 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 and I can't use side, angle, side. I just don't have that information. So if these are going to be similar, it has to be by angle, angle. And angle, angle is when we have two pair of congruent angles. Well, notice here I have a 32-degree angle and a 32-degree angle. That's one pair. And I have a 97 and a 97. That's a second pair. So yes, these are similar by angle, angle. All right, let's head on over to this example here. So again, notice none of my angles are labeled. None of them have a measure, none of them have congruent markings, so I know I'm not going to be able to use a postulate that has angle in its name. So my only option is side, side, side. Match up the sides. Again, start with, here's the longest side of this triangle was length 8. Match it up with the longest side of your other triangle, 4. Okay, move on. Here's the next longest side is 6, goes with the, oh, whoops, sorry, I matched up the first pair wrong. That would be 8 to 6 was the longest side of that first triangle. Then my second longest side over here was 6. My second longest side here was 4. I apologize. And finally, we have our shortest side, 4, with our shortest side, 2. Okay, now we are going to reduce each of these. 2 goes into 8 4 times. 2 goes into 6 3 times. Okay, so that reduces to 4/3. 2 goes into 6 3 times. 2 goes into 4 2 times. That reduces to 3/2. And finally over here, we reduce to 2 over 1. Okay, none of these are the same, right? So these are not similar triangles. The only option we had that would work would be side, side, side. And when we put our sides into fractions, none of them were the same. Okay, here's another. What's the relationship of JKL to JNM? Notice those are triangles, so we're talking about triangle JKL. And let me change ink real quick. Okay, the other one is triangle JNM. Okay, what's the relationship? Since we're in the section on similar triangles, I'm guessing that we're going for, are these similar or not? Well, let's take a look at what we have. Again, our options for proving two are similar is using angle, angle, two pairs of congruent angles, side, angle, side, which is one angle and two pairs of proportional sides, or side, side, side. Well, notice we don't know the length of this side here, and we don't know the length of this side here. So we don't have all three sides in each triangle. We can't use side, side, side. Angle, angle would require two pairs of congruent angles, and notice I only have one pair of congruent angles. So if these are going to be similar, it has to be by side, angle, side. So let's try that out. Let's try and match up. We have our angle in the middle. Okay, we've got the A part. They marked those angles as congruent. Angle L, they marked that congruent to angle M. So we're good there. Now let's match up our sides to make our fractions to see if they are proportional, see if they make the same reduced fraction. So here I am, line KL. Okay, that would go with line MN if we match up the corresponding sides. What is that going to be equal to? Well, we'd have 16 over 12 so far. Okay, this question is asking us what's the relationship between triangles JKL and JNM. We're dealing with similarity, so our thought is, well, are they similar? And if they're going to be similar, are they similar by side, angle, side, angle, angle, or side, side, side? Okay, well, let's take a look. For angle, angle, we would need two pair of congruent angles, and right now we only have one pair of congruent angles. Okay, to use side, 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 we'd need to the lengths of all three sides of both triangles, and notice we don't know the length of this side, and we do not know the length of this side. So they can't be similar by either of those reasons. Side, angle, side is a possibility. Side, angle, side, you need one angle in the middle of two proportional sides. Okay, so as long as this side here and this side here are proportional to the sides on those other triangles, we're good to go. So let's check that part out. Let's see if they make the same fraction. So when we write this down over here, we have KL. Now KL should match up with NM. Okay, so let's see. KL was 16 and NM is 12. Right, the other side that we know, and make sure you do it, we did the big triangle on top, so let's do the big triangle on top again. So we know the length of this side. Notice it's 24 and 8 more, or 32. Okay, so that's my JM, and it's going to go over, excuse me, my JL. Sorry about that, got my letters mixed up. It will go over the JM. Okay, well, JL is 24 plus 8, or 32, and JM is 24. We need to go ahead and reduce both of these fractions. Okay, let's see. 4 goes into 16 4 times, and 4 goes into 12 3 times. This reduces to 4/3.